Hello, welcome to Psych 319, Chapter 10, Part 1. Um, Today is going to be all about visual imagery, sort of mental representations and how we think and store concepts. I just want to start off by saying that this is a rather antiquated way of thinking about things, and historically psychology has dealt with this topic, but I think we've moved on to describing cognitive processes in different ways. So I just like to say that this, not that this information is invalid, but this is more historical than typically current. Um, so remember that the task for the visual system is to deconstruct the images that fall on the retina, which are two-dimensional, and recreate a three-dimensional representation of the world. That's a very difficult task. So how do you create this visual information in your mind, and how do we retrieve this information? So if you remember, we have capacity limits in short-term memory that prevent us from encoding all the visual information literally, so we have to create some kind of iconic representation of what's out there in the world. So at what point is the retinal image transformed into an icon? And do we use visual imagery to assist in encoding and recall? So visual imagery is very difficult to quantify. That's part of the problem in trying to study this phenomena. It's hard for me to think about what's going on exactly in your head at a particular moment when you're imagining something. You can describe it to me, but there's always this unreliability of the observer's report about what they're seeing, or even if they think they're using a visual strategy to solve a task, they might actually be not. Like memorizing a phone number, people might think, oh yeah, I totally am visualizing the phone number in my head, but usually what's going on is they're using an auditory loop to memorize the phone number. So there's that challenge. That's the classic, another way of putting it is, how do I know the color blue for me is the same color blue for you? I can't get inside your head, so we have to test things from the outside. And in general, the way we do this, we'll take physical measurements of the stimulus. That's something we have control over. And then we change the stimulus in some predictable way and measure the change in behavior. And we can measure your behavior. And then we quantify relationships between the input and the output. Since we can measure the physical changes of the stimulus and measure changes in your behavior, we can sort of look at how those two relate and hopefully make some logical assumptions about what's going on in your head and how you're representing information. And then there's also this fourth step where you can go in and take physiological measurements using MRI or other things like that, or maybe do animal studies and try and confirm that, let's say, for example, if it's visual imagery, you would expect visual parts of the brain to light up during a particular task. So I'm going to talk about a lot of mnemonics, and mnemonics are methods for memorizing information. We covered this in memory, but some of these are visual, and so historically they've been used to study visual imagery. Some are, some aren't. So this cartoon here on the right shows you a typical mnemonic for how people memorize the stabs in lines of music. So each line represents where a note would go, and so for example, going from bottom to top, the gaps might be F-A-C-E, and a mnemonic for face is a mnemonic for the notes, F-A-C-E, where they go. Another one would be something like every good boy does fine. Every good boy does fine. That's a way of making meaning that helps you memorize these notes. So that's just a general idea of what mnemonics are. They're memory tricks to help you identify or memorize large bits of information. But they might tell us how, some of them are very visual based, and so they might give us a clue about how memory works. So one of these is the method of loci. I'm going to go through these pretty quickly because they're all in the book. And that's the idea of associating a list of things to remember with location. So if you have a visual idea of where the location is, it should be easier to memorize whatever that thing is. So if you have an arbitrary list of items, and if you associate that arbitrary list of items with locations, you should do better at memorizing that list. So think about, like, if you found your house keys in the morning, what you typically do to find the house keys if you lost them is maybe retrace your steps, and you have physical locations associated with this process, and then maybe it assists you in the tasks. I forget the example of the pictures on the wall, so skip over that. So try and pick an arbitrary list of things like presidents or something like that. And then maybe associate presidents with various parts in your house and see if that helps you remember them. Imagine Abraham Lincoln in the bathroom and George Washington in the kitchen and so on and so forth. And create a really long list and see if that helps you memorize things. If so, then maybe we do benefit from visual cues for imagining long lists of arbitrary information. So for example, you could imagine bread on the counter, a dart in a painting, and a pen on the desk. I think you get the idea. Another idea is taking images and making them interact. If you have, let's say you needed to remember, something about picking up your kid from surfing lessons and maybe picking up a dog from the vet, and you have these two things that you needed to do, one way is create a single mental picture that combines those lists of things to do. So you imagine a dog riding a surfboard, and that single image allows you to remember a lot of the two things that you had to do. So creating interacting images might allow you to store more information or remember more information. And that's another type of mnemonic that's very visual based. And this is just a skateboard, a dog that skateboards, just randomly because I think I found it and thought it was stupid and funny. So there's another one, the peg word method, pairing a list of words to an already memorized list of words. The old list is composed of so-called pegs that you hang new words on. So an old list would be something that doesn't change. 1 is a bun, 2 is a shoe, 3 is a tree. Because they rhyme. Now, since you know the song and presumably have this in your head and memorized, you can associate new lists of items with those things. Like if you have new things to memorize like dog, cat, and horse, you can associate them with the previous list. So 1 is a bun, and you imagine a dog in a bun, like a hot dog bun. 2 is a shoe, so you imagine the second item in the list, a cat wearing shoes. So these are very visual ways of memorizing that new list. And some people report that this helps them memorize stuff. Chunking, a lot of this stuff we've talking about is an example of chunking, but you know that chunking is reorganizing complex material into more meaningful units. So if I give you this long list of numbers here and take it away, it's very hard for you to quickly remember what I showed you. Go ahead and test yourself. But if I give you something that is more meaningful, like if you associate them as a phone number and you break them up into little groups, 234, 765, 1093, then it might be more easy to remember because you think, oh yeah, 234 is easy because it's a kind of number that is easy to memorize in 765. So you might be able to chunk these long lists of information into shorter groups that make it easier to remember. Chunking doesn't have to be a visual phenomenon, but when it is, like in interacting images, the previous mnemonics, then it seems to point to the fact that we might use visual imagery to memorize some type of information. Acronyms are just basically representing long lists of items by some smaller chunk of information within that item. So to memorize all the colors of the rainbow, you use Roy G. Biv, and you might imagine a person, Roy G. Biv. The opposite of that is an acrostic, where you take information, you make it more complicated, but more meaningful. So if you wanted to remember the 4 corner states, you could say, can anyone name us? Colorado, Arizona, New Mexico, and Utah. And this is longer than the individual letters that would give you a clue to the states, but it might help you, the sentence might help you create a more meaningful list that's easier to memorize. So the grand question, do mnemonics do they prove information is encoded or recalled with visual imagery? So some people had hoped that they would. Many mnemonics use visual imagery, and visual imagery does seem to help recall. However, not many people use these in everyday life. Like the peg word method is a very obscure mnemonic that nobody seems to use. Like maybe 1 or 2 of my students have used this in any classroom, but it's very obscure and it's certainly not innate. So what is the point of all this? Does all this research that directly bear on the problem of how visual information is encoded or retrieved? Well, some of it does and some of it doesn't. And I'll get into that in the in the following slides. There are a number of hypotheses about how we are representing information, and one is the dual coding hypothesis. The idea of dual coding hypothesis is the more deeply something is processed, the better you can recall that information. So auditory information can only be encoded using the auditory echo, and visual images can be coded, as we know, using visual icons. But visual images can also be encoded using auditory echoes, because sometimes we transfer that information, the visual information, into an auditory echo, just like a phone number. You might see the phone number written down, but you translate it into an auditory echo. And so you might be encoding it both visually and auditorially, and therefore you might process it more deeply. And that, by that token, it's easier to memorize something using a visual image, because it gets really encoded in two ways. And that's the idea of the dual coding hypothesis, that it's more important and useful for encoding and recall because it's actually doing deeper, you're processing it deeper. And the way that this was tested was subjects were asked to memorize lists of paired words, and some of these words were concrete and very easy to visualize, and some were not. So a concrete word is something like a dog. A dog you can picture, a cat you can picture. And then an abstract idea would be something that is difficult to visualize, like liberty or vapor or energy or justice. How do you visualize that? So when people were given paired lists of words that were concrete or abstract or concrete, like dog, liberty, or energy, cat, the first word, they would do better. They would do better if the first word was concrete. So if the first word was concrete, it was better for priming the second word, which sort of indicates that we rely a little bit on this visual imagery to do some type of encoding or learning. And if the first word was abstract, it became much harder to encode the second word. So that seems to support the idea that we're using visual imagery in cognitive processing. And then there's another idea of the relational organizational hypothesis. And integrating images speaks to this. If you have a list of things, like I said, an independent list of tasks that you need to memorize, like pick up your kid from surfing lessons or pick up the dog from the vet, it's easier to encode that if you combine those images together. But according to this notion, visual imagery improves recall because it allows us to form more associations during encoding and more cues upon recall. So it's not the depth, but it's that there are more associations being formed between these ideas. And so subjects in one experiment were asked to memorize paired word lists. In condition 1, visual images did not relate, like the above images up here. And in condition 2, images were interactive. And of course, as you would expect, people did a lot better for images that were interactive. So there are two different opinions on what's going on, and the idea here is it's maybe not visual imagery, but maybe it's the associative strength that improves recall. And there are a lot of experiments in your book that address this idea, so look under relational organizational hypothesis and you'll see how these two theories go head to head, but I wanted to give you the sort of tip of the iceberg about what they were about. So I'm going to stop right here before we go into the hard evidence for supporting visual imagery, and see you in the next slide.